that x equals 4?
Well, primary school level. Now solve this.
What? That's not a challenge. The answer is that x equals 2 or x equals 3.
Well, you're supposed to know from one stuff.
Now solve this.
Wait, we can't factorize this, and it's not linear as well. Moreover, I can't draw the graph for this function. Are you kidding me? This is too hard.
When the equation gets too wild, we call it Newton-Raphson method.
Oh, I've heard of it. It's a method discovered by Isaac Newton and Joseph Raphson 300 years ago.
Suppose you are standing on top of a hill. Somewhere on the slope there's a ball, but you don't know where it is. You want to catch it, but you can't see it clearly. So, what do? You take a wild guess. You say, oh, maybe it's here, and build a ladder to that point. You climb up, reach the spot, and from there, you build a slide down the hill following the slope. You slide down, hoping to reach the ball. But no, you're close, but you miss it. So, you build another ladder at your new spot, climb again, check the slope, and build another slide. Getting closer, and finally, boom! You land right on the ball. You found the exact spot. So this is how the Newton-Raphson method works. You don't know the root of the equation, but you guess. You check the slope, derivative, and slide down to do a better guess. Repeat it a few times. Now this is the slide, and you get a second guess. And you climb down the ladder and build the slide again to get a third guess until you found the root. And so this is the Newton-Raphson formula.
Ah, I see. So that's Newton-Raphson. We guess, calculate, and then we zoom into the solution using slopes. I get it now. Oh, now I know how to do the question that was given to me earlier. So first, we should identify the equation, which is given here. Now, we should put it in a form that fx equals to the whole equation. And then we should differentiate the fx in order to get f prime x. And now we should make our first guess. So in this scenario, we are using 4. And we should sub this number 4 into the Newton-Raphson formula, which is given below. And after doing everything, we will get an approximate value that is closing in on the root that we want to find. However, this is only the first guess. We should now make our second guess. Using the approximated value that we found using the first guess, we sub it back into the Newton-Raphson formula. And then after a few tries, we will finally get our root, which is in this case 3.9094. That is the Newton-Raphson method. So, in conclusion, the Newton-Raphson method helps us to find the solution without having to solve the equation entirely. So, when the math gets tough, the tough keeps going. With this method, we have to do it a few times until we get an accurate result or an accurate solution. We don't panic. We think like Newton. We iterate like a boss. Learn deeply, teach simply. That's the Feynman way.